I'm going to take you through a technique called Siwoloboff's method, and it's a way of determining the boiling point of a liquid on a very small scale. You will be assigned some unknown liquid that you will dispense from the fume hood and take back to your bench, and you need to transfer just a little bit of this liquid into the small test tubes that will be provided. You want the sample in the small test tube to be about 1 inch tall. Now to that small test tube with your liquid in it, you want to add a glass capillary tube. But we don't want the entire capillary tube, we only want about 1/3 of it. So you can snap these off pretty easily, or the TA will have a glass file in the lab that you can use to cut this. And you'll take the capillary tube and invert it into the small test tube so that the open end is sitting down in the liquid. You will then take a thermometer and rubber band it to this small glass tube containing the liquid, and you want the bottom of the thermometer bulb to be just about even with the bottom of the test tube as shown here. Ultimately, this whole setup is going to be set down into a water bath. So this is what the whole setup needs to look like. You will take the piece that you just constructed, the test tube rubber banded to the thermometer, and you will connect it to a clamp through the thermometer, and you want to actually put your adapter on the thermometer to make it easier to clamp down. If you actually try to clamp down too hard on just the bare thermometer, you can snap the thermometer accidentally. And you need a magnetic stir bar, so your octagonal stir bar from your microscale kit down here at the bottom. Notice that you want the thermometer bulb and bottom of the test tube to be slightly above this magnetic stir bar. I mean, you don't want it to touch, but you want it kind of hovering in the middle of the water bath. And then this whole apparatus is sitting, of course, on a hot plate. Once you have this set up, then you're ready to turn on the heat and turn on the stirring. And so you'll see that your magnetic stir bar will start spinning. So obviously the water bath is going to start heating up, and the purpose of the stir bar at the bottom is to try to keep the heating even throughout the water bath. Now we want to take a closer look at what's actually going on in this test tube. What you're measuring with the thermometer is the temperature of the water bath. And this should be approximately the same as the temperature of the unknown liquid until the water bath exceeds the temperature of the boiling point of the unknown liquid. Initially, that temperature will be somewhere around 25 degrees Celsius or room temperature. And at room temperature, the unknown liquid should have a vapor pressure of less than atmospheric pressure, so less than 1 atmosphere. In the top of the capillary tube, you'll have mostly air, but also a little bit of the vapor from the unknown liquid. As the system is heated, of course, you will notice the temperature increase, but at the same time, the vapor pressure of the liquid will start to increase as well, and the vapors from this liquid will start to force the air out of the bottom of the capillary tube, so you should see bubbles escaping from the open end of the capillary tube. Eventually, all of the air that was in the capillary tube will have been forced out by the vapors coming off of the unknown liquid. And so the bubbles that you are observing will no longer be air bubbles, but they will have transitioned into vapor bubbles escaping. As you continue to heat, you will notice that that bubbling gets faster and faster. At some temperature, the vapor pressure in that capillary tube will equal atmospheric pressure, or 1 atmosphere. And this, by definition, is what we call the boiling point of the liquid. Now remember, what we are actually measuring is the temperature of the water bath itself. And also note that we will not be able to tell just by looking when the vapor pressure in the capillary tube is 1 atmosphere. So we're not going to be able to just record a temperature for a boiling point by watching it from this perspective. So now the question becomes, well, how are we supposed to figure out the boiling point using this method? And so the first thing that you want to do is to allow the temperature of the water bath to keep increasing. You want to actually, you want the water bath temperature to actually exceed the boiling point of the liquid. And you will notice that the bubbling will get very, very fast. And once you see rapid bubbling coming out of the capillary tube, then it's safe to say that you're probably past the boiling point. Once you see that rapid bubbling, you want to actually remove the entire setup from the hot plate. But the key thing is you do not want the thermometer or the test tube to come out of the water bath during this process. So I recommend having your neighbor help you slide the hot plate out, and then you want to sort of lower the entire setup down to a cork ring on the bench top. Now let's kind of zoom back in and talk about what's going on in that test tube. You will notice once you've removed the heat source that the temperature is going to start dropping. And initially the vapor pressure in there is still going to be holding out at 1 atmosphere because you have made sure that the water bath has actually surpassed the boiling point of the liquid. As the temperature drops, the bubbles will start to come out more and more slowly. The bubbling is going to keep slowing down until it nearly stops. And eventually, at some temperature, the vapor pressure in that little capillary tube is going to drop below atmospheric pressure. At this point, the bubbling will stop, and at the exact same time, so this pressure drops below 1 atmosphere, you're going to get a little tiny vacuum in the capillary tube. So it's essentially a straw at this point. And so some of the unknown liquid will actually get sucked back up into the capillary tube. When you see this happen, you need to record the temperature. So look for that liquid to get sucked back up and write the temperature down. This is the boiling point of the liquid. So when the vapor pressure equals the atmospheric pressure, this is the boiling point of a liquid by definition. The vacuum that you're seeing created is at the instant the vapor pressure drops below 1 atmosphere. So this is right at the boiling point. So the more quickly that you can write that temperature down, the more accurate your data will be. It all happens very fast. So to make sure that you have data that is good, you're going to need to do this at least 2 times, if not 3. And each time you repeat this, you're going to need to take out the old capillary tube, add some more fresh liquid so that it doesn't dry out, and then add a new capillary tube. You should be able to report the boiling point out to 2 decimal places.